If we clear out the lines, the most mesmerizing star I see is the star that could perplex our sky. It is this one, Creepy Crawly Jew or Creepy Crawly Jew. It's a red, incredibly epic star. Besides, in case you put it where the sun is, it would reach out to the circle of Jupiter. It's colossal, absolutely inconsistent, and going to explode. It's not as clear as it appears to be in the universe. These monstrous occasions, like the absolute most feared enormous starbursts, could shake all that we notice. Regardless of whether we see its center, Insect Jew has been viewed as a sign, a red, unimaginably giant star. It is incomprehensibly larger than our sun. Brian Cox and other space specialists suggest it could go supernova, which has made people anxious about what will happen next. The James Webb Space Telescope is capturing stunning images of the star, raising the question of when Creepy Crawly Jew will transform into a supernova and what titanic impact it could have on Earth. Let's explore the star in the heavenly constellation of Orion, which shines so brightly that even ancient civilizations noticed it. The brilliant star, Betelgeuse, is situated on the eastern shoulder of the constellation Orion. It is the second largest star in the star group, and its name comes from the Arabic expression meaning giant shoulder. It is possibly one of the brightest stars in the night sky. On top of being incredibly bright, the star is also an odd shade of red, which, as we will see, suggests trouble. Humankind has known about Betelgeuse for a very long time. A Greek observer named Tmy described it around that time. The main thing people noted about stars was their color, and Tmy described it as having a rosy orange tint. In modern times, scientists have focused on the star more closely and now have a clearer understanding of what makes it exceptionally bright. One of its attributes is that the star changes brightness significantly, with an apparent magnitude of 0.6. Betelgeuse is a variable star, meaning its brightness changes over time. In 2019, scientists first observed that Insect Jew was acting unpredictably. Although it didn't completely stop shining, it had become significantly dimmer, with its brightness dropping to a magnitude of 1.6. Scientists quickly began investigating this unusual behavior. Researchers offered astounding explanations based on their findings, which revealed abnormal signals from the star. According to their discoveries, Creepy Crawly Jew could go supernova at any moment. Brian Cox, a renowned scientist, shared this startling possibility. As a professor of particle physics at the University of Manchester School of Physics and Astronomy, Cox's viewpoint is hard to dismiss. He also hosts science shows, writes popular science books, and serves as the Royal Society Professor for Public Engagement in Science. Cox has described Insect Jew as a ticking time bomb that could explode without warning. To complicate matters further, the James Webb Space Telescope has provided significant evidence supporting this claim. But what unusual signs has Insect Jew displayed that have caused such concern among astronomers? With new data about Betelgeuse, the star has been labeled a supernova candidate. However, researchers are still uncertain about when it will explode. One reason for this classification is that Insect Jew is twice the mass of the Sun. A star must be several times the Sun's mass to be considered a supernova candidate. Scientists have used various tools, such as the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, LIGO, to study the phenomena surrounding Betelgeuse. What they have found remains a mystery. It is believed that Betelgeuse was born roughly 10 million years ago, a relatively short lifespan for a star of its mass. Over time, the star has displayed unusual behavior that makes its future uncertain. Scientists have identified peculiar light waves emanating from Betelgeuse, which add to the mystery. One of the more striking observations is that Betelgeuse's brightness diminishes and brightens periodically. This variability has been studied for decades, but in 2019, something unusual happened. Creepy Crawly Jew experienced what is now referred to as the Great Dimming. The star's brightness dropped dramatically by 1.2 magnitudes between late 2019 and early 2020. This event marked the dimmest the star had ever been recorded in modern history. It sparked great interest among astronomers, as many believed it signaled an imminent supernova. However, by 2021, Betelgeuse began to brighten again, puzzling scientists and reigniting interest. Astrophysicist Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics noted that Insect Jew was shining 150% brighter than usual, making it the seventh brightest star in the night sky. This surprising increase in brightness has led to various theories about the cause of the great dimming. One explanation is that Betelgeuse ejected a massive cloud of material, creating a dust cloud that temporarily obscured its light. The James Webb Space Telescope has provided critical data supporting this hypothesis. Scientists observed a mass ejection event significantly larger than typical coronal mass ejections from stars. This mass release is believed to have produced dust clouds that cooled and darkened, effectively blocking Betelgeuse's light from reaching Earth. The James Webb Space Telescope has captured detailed images showing these dust formations resembling leaves in space. Despite the dramatic events surrounding Betelgeuse, scientists caution that a supernova may not happen anytime soon. Although Betelgeuse is nearing the end of its life as a red supergiant, predictions suggest it could take thousands of years before it finally explodes. If and when creepy, crawly Jew goes supernova, it will be the first such event observed with the naked eye since Johannes Kepler documented the 1604 supernova. Scientists are eager to witness this phenomenon, as it would provide valuable data about the life cycle of massive stars. That said, there is no need for alarm. Betelgeuse is approximately 640 light-years away, meaning its explosion would pose no immediate threat to Earth. Instead, it would create a spectacular, celestial event visible even during the day. Astronomers continue to monitor Betelgeuse closely, using advanced instruments like the James Webb Space Telescope to track its behavior. This star, one of the most fascinating in the universe, remains a subject of intense study as scientists work to unravel its mysteries. A giant star like Betelgeuse is a perfect case study for understanding the end stages of stellar evolution. Its massive size and unpredictable behavior give astronomers insights into what happens before a star goes supernova. The eventual explosion will not only be a spectacle, but also a significant event for scientific research, offering clues about the formation of neutron stars, black holes, and the distribution of heavy elements in the universe. When Betelgeuse does explode, the resulting supernova would likely be bright enough to outshine the moon in the night sky and even be visible during the daytime for weeks or months. The light from the explosion would travel across space for about 640 years before reaching Earth, meaning that it could have already exploded, and we wouldn't know it yet. However, the explosion's impact would remain far enough from Earth to avoid harm. The energy released in the form of gamma rays, neutrinos, and other cosmic phenomena would not significantly affect our planet due to the star's distance. For scientists, this event would be an unprecedented opportunity to observe and study a supernova in real time using modern technology, including telescopes like James Webb and instruments designed to detect gravitational waves. Betelgeuse's fate serves as a reminder of the vast and dynamic processes at play in our universe. Stars like this, while nearing the end of their lives, contribute to the cosmic cycle of life and death, dispersing elements that are vital to forming new stars, planets, and even life itself. In the meantime, astronomers remain vigilant, monitoring Betelgeuse's every flicker and pulse. As our understanding of stars and their life cycles deepens, we continue to marvel at the beauty and complexity of the cosmos, a testament to the boundless mysteries that lie beyond our world. Direct terms, extraordinary vainglorious events like galactic impacts might possibly totally agitate our viewpoint. An occasion of this nature may probably occur anyway. While the chance of Betelgeuse going supernova looms, specialists are still attempting to decide the specific succession of events leading to its end. As researchers continue to gather information from the most advanced space telescopes, such as the James Webb Space Telescope and the Hubble Space Telescope, they remain wary about predicting an inevitable blast. Regardless of the star's amazing conduct, including its baffling darkening and lighting up cycles, there is no assurance about when Betelgeuse will at long last reach the finish of its life. Some estimate that it might still take a long period before the star detonates, while others believe it could happen much sooner, maybe within the next couple of years or even months. The extraordinary information gathered by these powerful telescopes, alongside the star's unusual behavior, has kept specialists fretful. They are cautiously monitoring each subtle change that could indicate a cosmic explosion is imminent. When Betelgeuse does finally detonate, it will send shockwaves through the universe, releasing a gigantic amount of energy. The blast will quickly dominate the whole sky, appearing as bright as the full moon from Earth. While this event will be a glorious, inestimable presentation, it will not pose an immediate danger to Earth, as the star is found more than 600 light-years away. Anyway, the supernova will provide a huge opportunity for researchers to study the final stages of a massive star's life and the peculiarities related to such a violent event. Betelgeuse's looming end isn't simply a scientific curiosity. It is a sign of the immensity and oddness of the universe. Stars like Betelgeuse play an essential role in the life cycle of galaxies, enriching the universe with the elements necessary for new stars, planets, and possibly life itself. The death of such a star isn't an end, but rather a transformation, as it releases heavy elements that will ultimately seed new stellar systems. In the meantime, researchers continue to observe Betelgeuse and its behavior, unraveling the mystery of its future. With each new discovery, the riddle grows, and our understanding of the universe expands. Maybe soon, we will witness one of the most unprecedented events in the universe: Betelgeuse's transformation from a massive red supergiant into a spectacular supernova. Until then, the sky will remain a canvas of marvel, with Betelgeuse shining brightly, a symbol of the transient nature of life in the universe. As we continue to monitor Betelgeuse, the mystery surrounding its fate grows. Space researchers are particularly focused on the fact that this star is approaching the end of its life cycle and exhibiting erratic behavior. The unusual activity, stirring such great interest, reminds us that not all stars end their lives the same way. For instance, smaller stars like our Sun will end their lives much more quietly, shedding their outer layers and leaving behind a white dwarf. However, Betelgeuse is a massive red supergiant, which means it will go out with a spectacular bang, immensely different from the slow fading of smaller stars. The sheer size of Betelgeuse makes it a fascinating subject for study, with a span many times larger than the Sun. If placed at the center of our solar system, it would extend beyond the orbit of Mars. This gives a sense of just how gigantic it is compared to the Sun, which is already enormous by the standards of most stars. Betelgeuse's size means it has consumed vast amounts of fuel throughout its life. As it moves toward the end of its life, its core is rapidly collapsing under the force of gravity. This breakdown eventually triggers the violent explosion of a supernova. The process leading to Betelgeuse's explosion is complex. As it nears supernova status, the core of the star begins to contract and heat up while its outer layers expand and cool. This creates an unstable environment with intermittent variations in brightness. These changes in brightness, like the dimming event seen in 2019, are signs that the star is entering a period of rapid change. This darkening might be linked to the release of material from the star's surface, which briefly clouds its light. Despite these fluctuations, Betelgeuse continues to emit light, but erratically, making it a captivating object for study. The possibility that Betelgeuse may be a candidate for a nearby supernova has drawn the attention of space agencies and researchers worldwide. With current instruments like the James Webb Space Telescope and the Hubble Space Telescope, researchers are gathering an abundance of data on the star. These telescopes allow us to observe Betelgeuse in previously unavailable wavelengths, such as infrared and ultraviolet light, providing insights into the star's internal processes. Moreover, scientists are using advanced models to simulate the behavior of massive stars like Betelgeuse. These models help researchers predict the star's future behavior and estimate the timeline for its explosion. While the exact timing of Betelgeuse's supernova remains uncertain, current data suggests it could happen soon. Some predictions propose that the explosion could occur within the next couple of years, while others estimate it might take several thousand years. Regardless of the timeline, Betelgeuse's impending demise will undoubtedly be a milestone event in the study of stellar evolution. Although Betelgeuse's explosion will not pose an immediate threat to Earth, it will still offer researchers a significant opportunity to study the final moments of a massive star's life. By observing this event, astronomers will gain a deeper understanding of how massive stars die and what happens when they go supernova. The remnants of the explosion will provide new elements and materials that will enrich the interstellar medium, contributing to the formation of new stars. In all, Betelgeuse is not a star that will fade away quietly. It is a cosmic clock ticking down to a magnificent event. As scientists continue to observe this giant of the night sky, we are reminded of the wonders of the universe and the delicate balance that governs the lives of stars. Whether it's tomorrow, hundreds of years, or centuries from now, when Betelgeuse finally reaches the end of its life, it will leave a legacy that will shape the universe for billions of years to come. As Betelgeuse's inevitable transformation approaches, it will not only be a defining moment in the study of stellar evolution, but also a reminder of the cyclical nature of the universe. The death of a massive star like Betelgeuse marks the beginning of new possibilities. Its supernova will scatter essential elements like carbon, oxygen, and iron into space, enriching the surrounding interstellar medium. These elements are the building blocks for future stars, planets, and even life. In this way, the demise of Betelgeuse will not be an end, but a contribution to the ongoing creation of the cosmos. Once the supernova occurs, the remaining core of the star may collapse into a neutron star or even a black hole, depending on the mass of the core. These remnants will continue to provide valuable insights into the nature of dense objects in the universe. Neutron stars, for example, are some of the most extreme environments in nature, with magnetic fields billions of times stronger than Earth's and densities so high that a single cubic centimeter weighs as much as a mountain. Studying these remnants can help us understand fundamental physics, such as the behavior of matter under extreme conditions and the nature of gravity in regions where it is most intense. The explosion will also serve as a natural laboratory for astrophysicists, who will be able to observe the behavior of matter in the wake of the blast. This includes studying the shock waves, the emission of light and radiation, and the interactions of the expelled material with surrounding space. The supernova could even be visible to the naked eye from Earth, a rare and awe-inspiring sight, depending on when it happens. It will be a cosmic spectacle that will draw attention from astronomers, scientists, and the public alike, as people witness the dramatic end of one of the most iconic stars in our sky. While Betelgeuse's eventual explosion may take place far in the future, its impending end raises important questions about the life cycles of stars. How do different types of stars die? And how does the process vary depending on their size and mass? What role do these explosions play in the formation of galaxies and the evolution of the universe itself? These are questions that researchers are eager to answer, and Betelgeuse provides an invaluable opportunity to gain deeper insights into the life and death of stars. Moreover, the study of Betelgeuse offers a glimpse into the future of our own Sunday. While our star is much smaller than Betelgeuse and will die more peacefully, its eventual death will follow a similar pattern. It will exhaust its fuel, expand into a red giant, and shed its outer layers. The remnants of our sun will also contribute to the formation of new stars and planets, continuing the cycle of creation in the universe. However, the fate of our sun will occur on a much longer time scale, and we have billions of years before we must worry about its end. For now, Betelgeuse remains a celestial enigma, a bright and captivating object in the night sky that continues to fascinate astronomers and stargazers alike. Its eventual explosion will be a profound moment in the history of the universe, a cosmic event that will forever alter our understanding of the life cycle of stars. It will also serve as a testament to the incredible forces at work in the universe, forces that are beyond our comprehension, yet intricately tied to the ongoing creation and destruction that defines the cosmos. As we await the eventual supernova, scientists will continue to monitor Betelgeuse, gathering more data and refining our understanding of its behavior. The discoveries made in the years leading up to the explosion will no doubt advance our knowledge of the universe, uncovering new mysteries and pushing the boundaries of what we know. And when Betelgeuse finally reaches the end of its life, it will not just be the end of a star. It will be the beginning of new questions, new discoveries, and new insights into the vast and ever-changing universe that surrounds us.